Welcome to modifications to a Stuart beam engine part 4, fixing the mounting block to the baseboard and drilling the holes to mount the pedestal in the correct position. Another test run and seeing the cylinder wobbling and leaking. This problem needs rectifying and I know what is causing it. The job starts by verifying that the holes in the baseboard are in the same place as the holes in the block that the engine's mounted on, and the good news is, yes they are. A viewer commented that my voice was not the same as usual. I'm really not surprised. 6 days ago I had a 5.5-hour operation to remove a kidney, and this has affected a good bit more than my voice. I'm assuming that it will get better with time. Talking about time, it's top tip time. The holes in the pedestal are only 1/8 of an inch in diameter, and I need to make a mark on the board through these holes. My felt tip pen deep hole marker is long gone, so I've decided to use a method that works very well. Just sharpen a pencil on the belt sander as shown here. Make it thin enough to fit down inside the deep hole so you can make a mark on the wood underneath. This is actually far better than a deep hole marker because the felt tip pen type ink tends to smudge all over the wood that it's being marked on. Drilling an 1/8 of an inch diameter hole with my Proxon motor tool in this oak is quite difficult. It seems to give off a lot of resin and gets very sticky, and the motor tool keeps stopping as it's being overloaded. I thought it was a good idea to revert to my Bosch full-size battery-powered drill. Because it has a 2-speed gearbox, it's really easy to slow it down, and the drill bit went through the oak very easily. This pedestal has been designed to take 5BA bolts, and I have some long 5BA bolts but not that long, so what I'm doing on the underside is using a larger twist drill with a piece of high density rubber tubing on the end to limit the depth. The last thing that I want to do is drill all the way through the wooden base. Using a piece of high-density rubber tubing on a drill is useful because if you put more pressure on the drill bit, then you get a deeper hole, and the rubber tubing moves on the drill, so when you drill the hole next to it, it's the same depth. You have to be careful, but it does work. A caution though, this is not silicone rubber tubing, it's very high-density rubber tubing from a high-pressure air hose. The next job is to permanently mount the board to the actual block on the engine. And to prevent the problem of chewing up the head of the screw, I'm using the ratchet clutch that's built into the drill, very useful. I put a steel washer on one of the 5BA bolts and pressed it into the hole. And believe it or not, even though I'd previously machined down this socket driver, it was too wide for the hole, so instead I used my very thin long nose pliers, just to hold the head of the bolt while I fitted the washer and the nut on the other end as shown here. And then I tightened the nuts at each side of the pedestal, and it's now a very good tight fit. It really is quite important when building steam plants or even stationary steam engines on display plinths to fit some sort of feet underneath. This will prevent the underside or any particles on the underside of the plinth from marking any surface that the engine is resting on. These are some that were given to me by a friend, and they're really good. They're made from felt so they don't compress. The foam type stick-on feet tend to be a bit on the squashy side, and over time they get sticky. Time for another compressed air test. And if you look carefully, you can see the cylinder rocking about. It's really loose, and hazarding a guess, I think I know why this is happening. This engine, as well as the Twin Victoria, are both factory machine kits, but the owner of the engines, who put them together, decided to modify certain aspects. He certainly wasn't an engineer or a musician like me, and what he did was he enlarged the parts to make them smoother. There were never interference fits, they were perfect fits, but a little bit on the tight side, as you would expect from a new engine. And I think what he's done here is opened up the countersinks on the metal plate that the cylinder's bolted to, so it moves around, because the countersunk bolts cannot go far enough into the cylinder. I will rectify this and all should be well shortly. I'll show that in a future episode. Now the engine is solidly mounted onto the plinth, it's running a lot better. It's still extremely retarded, but it's fairly smooth, even though the cylinder is wobbling about. Have a look at this close-up in real time. The steam cylinder is a very important part of a steam engine, and rule 1 is the cylinder needs to be fastened down very tightly. That's it for this episode. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.